So Virtual Brisbane, what is it? Virtual Brisbane utilises innovative 3D technology to help us plan for our growing city. It assists with decision-making and providing visualisation, and now more so than ever, analysis, to help us see Brisbane in a more realistic 3D context. At the moment, it plays an integral role in strategic planning and policy development. We use it for development assessment for major projects and for community engagement and consultation. Now, Virtual Brisbane this year celebrates its 10-year anniversary. It began in 2008 as a transition from a physical to a digital model. What you can see here in the top right over here is the old physical model, and that's just across the river at QUT. So if you ever want to see that, give it a visit. Our Virtual Brisbane base model, what is that? It spans the inner 5 kilometres and 4 major growth corridors. That's about 140 square kilometres. It's generated using a process called aerial photogrammetry, captured from light aircraft at a couple thousand feet up in the sky. Now, Gordon started to introduce this concept, but I just wanted to reiterate it. At the moment, there's probably 2 types of city-scale 3D models. You've got integrated meshes, or reality meshes, and then you've got city information models, and that's what I'll call Virtual Brisbane. You might also know that as a semantic model or city GML LOD style model. Both have its pros and cons. If I had my way, I'd have both. The advantage of the reality mesh model is that it's of high visual detail. A potential con is that it's typically one surface or one object. On the flip side, for these city information style models, you've got potentially lower detail, but then each object can be individually modeled. And going on from that, Virtual Brisbane consists of about 150,000 different objects, fully photo textured as well. The base model is refreshed every 2 years, so that's where we commission a new light aircraft or flyover. But in the interim, we'll keep it up to date with major developments, with applicant-supplied models or with models we've generated ourselves. It's a spatially accurate model, accurate to about 0.5 metre. And I note that I'm quoting these resolution and accuracy items here. They're covering the entire model. So within the key coverage, within the key areas such as the CBD and centres, that's probably conservative, but that's covering the entire model. And it's in MGA Zone 56. Portions of the model can be made available externally under a license agreement for council business as well. Now, Gordon and Megha to a degree addressed this, but I'd like to continue this even further. GIS and BIM. So here we've got the spectrum of GIS and BIM. On one side, you've got GIS, which is traditionally macro detail and 2-dimensional. And on the other end, you've got BIM, or building information modelling. I probably would prefer to drop the building term and call it better information modelling or management, because it's not just about buildings. And this is where we go into 3D, 4D, add as many numbers and Ds as you want there. The Virtual Brisbane base model itself probably sits in the middle of this spectrum. The work the project team does probably touches on all parts of this spectrum here. With GIS and BIM integration, the key here is a lot of people are using a lot of different types of software platforms and file formats. So one thing that really works with our workflow is being able to be compatible across as many formats and pieces of software as possible. In that end, we're excited to hear about the Esri and Autodesk partnership, and we expect to see a lot of new interesting things there. Again, reiterating the city-scale information model side of things, whereas a BIM model might have all your detail about drainage pipe widths and all those particulars, the Virtual Brisbane base model itself is probably, at this point in time, more considering things like when was a building built, maybe what sort of roof type it has, so the type of information relevant at a precinct or city scale. Again, given that we're in a city planning context, that's usually how these things happen. 3D models of cities usually get commissioned to begin with city planning, but then it might move on to other lives later on. So at the moment, it's used predominantly for planning and contextual understanding. And as data standards mature and interoperability increases, we hope to see more integration. Now, our workflow in 2018, what does it look like? Well, first of all, there isn't a piece of software that you double-click and just say, yeah, Virtual Brisbane, go. It's a very complex workflow that involves a lot of data inputs and processes. Of course, we have to start with a base model. Currently, the base model is provided by AAM as a semantic or city information or LOD style model. We then supplement this with other 3D content. So this could be architect-supplied 3D models, 3D models we've generated in-house, integrated mesh models. We can then blend with what I'll call the corporate GIS data. So this is what my colleagues in the Council's official GIS department look after. So this might be the digital elevation model, aerials, the city plan mapping layers. Then there's the specialized GIS layers. So sitting beside me at work are the project managers of projects that look after development application tracking in the city, land use tracking. So you could see the obvious benefits there for city planning. And also we supplement the data with citywide LiDAR data set. So what do we do with all of this? Predominantly, it's a GIS and 3D modeling workflow. So we put these inputs through these processes. So our bread and butter heavy lifting is done in ArcGIS Pro. I'll talk a lot about City Engine later for more procedural modeling and scenario analysis. And going towards the cloud, we're really looking forward to what ArcGIS Online offers, and we've begun to use that. In the 3D modeling world, we use a lot of Revit for BIM stuff and 3ds Max for traditional 3D modeling. And although I've got it in this little box under here, under other processing, this is probably the most important part of our workflow so far, and it's a glue that keeps everything together and allows us to deliver our outputs. But as Gordon was mentioning before, there's a lot of data cleaning involved, ETL. We also have our model in gaming engines, so we're excited to see the relationship between Esri and Unreal there. We do lots of rendering as well, and other post-production and a lot of other software fiddling. So why do we do all this stuff? We produce a lot of video and still renders. We're beginning to produce more and more 3D web scenes and virtual reality outputs. And the humble 2D map and analysis as well, we still do a lot of that. And why do we do this sort of stuff? Ultimately, it's for evidence-based urban planning. Often what we do is very complex. So what we're able to do is, through this 3D process, communicate very technical topics simply. And ultimately, it's for better outcomes for the city. To go very quickly through a function evolution of Virtual Brisbane and what's happened over the past decade, it's very much started off in the realm of visualization when 3D was rather novel. We're now deep in this territory of using it for data integration and analysis, using it to help support and inform land use policy and strategies and development applications. But what I'm most excited about is what I'm calling today next generation planning. So this is getting more information in there. So enriching the city information model with more building attributes, like I mentioned before, building ages, land use per floor level, that sort of stuff. Ultimately, we want to do this for wider integration and interoperability. Yes, the model spends most of its life in urban planning applications, but you could imagine the applications for smart city uses for the model. I'll talk a bit about what we do in terms of development assessment. I won't go through all this sort of stuff here. You probably appreciate, given the crowd here today, that it's potential uses for real-time shadows and view sheds and all that sort of testing side of thing. But what I'd like to emphasize today is culture change. So if you take a look at this link below, it's a publicly available link. So Virtual Brisbane 3D requirements. So whenever someone has to provide us a 3D model, we direct them to this form. And it's not often that I'll go talk about a form in one of these conferences as opposed to some fancy pictures over here. But this is really important because it answers all the questions, so hopefully most of the questions that people will have. If someone is to submit us a 3D model, we direct them to this link, and it'll answer questions like intellectual property. What file formats should I submit? What should I keep? And what should I delete from the model? To sum that up very quickly, at the moment we take a variety of file formats, FBX, DAE, OBJ, SketchUp, but we're really piloting the use of BIM formats. So for the Revit users there, we would like to use that more, and in an open approach, we like to take more IFC files. Now, I hope the IT gods are smiling upon me today. I'll do a few videos and demos here. So what I would want to show here is a time lapse. So this time lapse shows how the CBD has grown from 1946 to the current day, and using our development application information, mass models of approved future development. So we're using a 1946 aerial base here, and you can see as buildings pop up and bridges, we can start to animate how the city has transformed. And of course, there's a bit of 3D, magic dust on here, fancy rendering and animated buildings that grow. And this is another benefit of having individual objects as well. It's easier to be able to do this and stage the development here. And what we'll probably hope to see to begin are the approved buildings. You can see Queen's Wharf there and the various other buildings there that are approved. So I'll spend a bit of time now going through some demos of the work that we do. A lot of the work we do is procedural modeling. And procedural modeling allows scenario analysis. And key to that for us is City Engine. I think we've been using City Engine for almost 10 years as well, so it's certainly bread and butter of the virtual Brisbane workflow. So could I just see a raise of hands? Who here has heard of procedural modeling or anything similar to that? Okay. So this graph sums it up pretty nicely. So if you were to hand model buildings, it's a fairly linear relationship. The more stuff you have to model, the more time it'll take. But with procedural modeling, I like to say what we want to be doing here is making rules, not shapes. So you spend more time up front specifying rules. So these rules might be the building can be such and such setback or such and such developable area. And you can then garnish that building with various cosmetics like roof types and all colors and all that sort of stuff. So you can see this stuff takes time up front, but it doesn't matter if you're doing 10 buildings or 100 buildings or 10,000 buildings. It doesn't take too much time additionally later on. So in this example, what we're asked to test is what happens to the streetscape and how a human would experience a street if we were to increase plot ratio and allow more plot ratio. So what we're able to do is code these rules to begin with, drag a slider for plot ratio, and what you can see here is as the plot ratio increases, we lose variation in the building forms. So the streetscape becomes a lot more monotone. Then also what happens is that we lose space to put things like deep planting and communal open space. So this is the benefit of procedural modeling and City Engine, where you can do both the visualization and analysis in one hit. We've coded a few other things into this as well. So when you're non-compliant with setbacks, the setbacks go from green to red. And it's basically as many things you can, if you can think of a way to code it, you could show it procedurally. Of course, as well, you have metrics alongside here. So we can track how plot ratio affects gross floor area and other metrics if you want to put them in there. I'll go to another demo here of some 3D story maps that we're beginning to use. So in this case, we brought this out to a public consultation event. And the intention here was to step through the key parts of a planning scheme, or a city plan, that would determine what a building would look like. So in this case, we're looking at an example large site, and what would a potential multi-building residential development look like? So here we've got a bit of text on the side here. We can take a look around the example site. Note also we're using Esri's sketch line tool to reinforce that this is a concept. So the next stage is introducing the developable envelope. So for those of you in the room who are familiar with the built environment industry, this might be a no-brainer, but the intention of this is to roll it out so that everyone can understand it. So planning schemes are very complex. They involve a lot of text. You'll be referring to, if you've seen the movie Inception, Dreams Within a Dream, you've got a table that you have to refer to another table, and it's quite complex. So what we're able to do here is say, hey, let's interpret this, make it a box. So what this box here is, it isn't showing the final building at the end, but it's showing the developable envelope, which is compliant in terms of allowable heights, transitions, and boundary setbacks, Also annotated the boundary setbacks here in these yellow markers, and you can see there's a compliant outcome. So now we've established, we've got the site, we've got a developable envelope, which indicates what built form could go inside here. The next step is to introduce indicative buildings. Now this is where I just want to emphasize that I love this stuff, this is great, but these are just tools. At the end of the day, you need good city planners and good decision makers there to build a better urban environment. Ultimately, cities are for people and they should be designed by people. So in this case, what we've done is that we've assumed, hey, what's going to happen in a two-building development situation here? So that's what we started off with. 2 buildings, we put this into City Engine, and it spat out an indicative building floor plate, which is compliant with things like plot ratio, site cover, lengths, widths, and that sort of stuff. We've finessed this one a little bit more in more traditional 3D workflows to be compliant with building articulation and a few other things there. And again, using these yellow indicators, we can see that in this case, our built form here is compliant in terms of building separation. Then ultimately, we go to an artist's impression. So this is where we garnish it further, and we start to introduce things, still through procedural modeling, such as compliant deep planting and landscaping and vegetation cover, communal open space as well. We're able to procedurally generate parapets, lift overruns, and other things like that to give the artist's impression more realism. So what we're trying to do here is really strike that balance of what's compliant in terms of a planning scheme and what's something that's visually garnished so that anyone can understand this. Going back to the presentation. Now I'll go through a demonstration of a browser-based web scene. So we're beginning to use these more and more in-house. So this is the virtual Brisbane city model with a lot of extra data loaded in there. And we're beginning to use this internally, not just within our team, but giving this to the urban design team or other teams so that they can go beyond might just be a 2D map that they use in a web browser, but really bring that into the 3D world and to enrich it with other data sets. So as you saw before, there's the 3D development approved activity data, which is represented in these mass models. So what we're seeing here is the Brisbane River. We're not too far from this location, actually. This is a new development on George Street, which will eventually be 3 buildings. And this is what's shown at the moment. So I'll just turn off the buildings that haven't yet been built. And what we can see here is a as-built model supplied by the developer of the hotel there. I don't know, maybe some of you guys are lucky enough to stay there tonight or over the weekend. Also, in this model, in this web scene as well, we've got the aerial laser scan data. And you can see here, this was taken a few years ago when the law courts were still around. So that's why you see this, this red bit up here. Probably the next thing I'd like to step to is the catch with aerial photogrammetry is line of sight. You can only model what you can see. So if you're up in the sky, there's going to be occlusions. So the next step is to get more detail, to get more resolution. So this is down Queen Street Mall now. So what I'm showing you here is just what I can do with a DSLR with no fancy surveying or laser stuff. It's just the bare minimum from a DSLR. What I'm also showing is what's likely to be consumed by the people within our team. So we also do have a high resolution version of this where you can see each individual crack, but what I wanted to show today is realistically what are we going to use day to day, not in a fancy editing software. So this is all within ArcGIS Online, and as you can see here, we can see nicely underneath, and we can even start to measure things as well. So let's measure underneath here. So we can get some distances. We can measure to our heart's content the facade of the building that's on the top of Queen Street Mall. Zooming back, at a wider context level, we can then turn on shadows And so we can get to understand shadow impacts of proposed development. This is where we have it currently. Going forward, what I'd like to see is increased use of building attribution. So I can click here, get some attribute information about this building. For this one here, we can click that, and we can see the development application number, the height of the highest part of the roof, and other information there. Going forward, what I like to see is being able to query this, so we can quickly show, okay, what parts of the city are over so-and-so AHD and this part of land use, this type of land use. Or I'd also like to see real-time view sheds and line of sight built into this, which I'm pretty sure are coming soon with some Esri products. So going back to the presentation now. Virtual reality. You can't go to one of these things without talking about virtual reality, so I'll do that. So what our initial rollout has been like is that we've been using essentially 360 photos or 360 panorama photos in a mobile context. So that's the Samsung Gear VR. And we use City Engine and lots of other tools to develop these products. We're predominantly using them for engagement and communications. Those are some of the events that we've taken it to. So ECA, which, if you're not from Brisbane, is sort of our key Royal Agricultural Show. Lots of industry events and community consultation events. And I'll probably bring it back to an example where I was at one of these community consultation events, had the headset, a family came over to me, didn't care about town planning, right? They just wanted to see a fancy thing in virtual reality. And from that, we managed to get a really good conversation about town planning and what the city might look like, which would have never happened otherwise. So you might dismiss it as something that's a bit tokenistic for now, but it's really beginning those conversations and being able to engage people who otherwise probably wouldn't have been interested. Going forward, we're particularly interested in how hardware standards and software standards are maturing, and how software is beginning to integrate with this. So I mentioned before Unreal Engine. We use that currently, so I want to see a stronger integration between the gaming engines and GIS tools. Along the hardware and software standard side of things as well, really interested to see particularly where markerless augmented reality is going as well. Just want to show here an example. It's hard to convey these VR outputs on a flat image here, but this is what we rolled out at a community consultation event. So this is of Kangaroo Point, and this is of the Dockside development. So what we did here is we did, in a virtual reality headset, a comparison of 1986 Kangaroo Point to the current day. And as you can see here, we've got quite a built-out situation here, and what was previously empty here before Dockside was developed. This is a great example of how we use multiple tools to get to this. So to get to this, we used 1986 aerial imagery. From that, we got an understanding of where the vegetation was and building footprints. And from that, we were able to procedurally generate buildings, texture them appropriately, and vegetation as well. Okay, going forward, what's in store for Virtual Brisbane? So in 2019, we're looking to update and refresh, hopefully expand the base model as well. We look forward to more cloud and web browser integration and moving the model to that environment. From a high-resolution 3D model point of view, I showed you that example before along Queen Street Mall, but we hope to be able to use drones more often and handheld devices to supplement and build high-resolution 3D models in areas where we might need them. Really looking forward to embedding more data and attributes into the city information model and wider integration and interoperability as well, so that this thing can be continued to be used for community consultation. But you probably saw before what Hub enables for community consultation and urban planning, and tools like ArcGIS Urban, which will allow you to integrate not only the 3D model, but other models such as other information such as employment or land use there. So just a quick recap of benefits and outcomes to date. Virtual Brisbane is a means for quick and easy and accurate visualization and analysis of built form, and we can understand the compliance impacts there. Now, I like to stress this part here. Key to Virtual Brisbane is its workflow. It's based upon multiple software tools, and it's based upon being flexible in being able to take upon as much data as possible. So import and export freedom is critical to us. Yes, we have a base 3D model, but we supplement that with as many data sets as possible, be it CAD, GIS, BIM data, development approval data. Ultimately, we're using it for analysis and testing of planning scenarios to inform land use and planning policy. And at the end of the day, I hope it results in evidence-based planning and using it to paint a picture of what the future could look like. So thank you for your time today, guys.